Hello students, today let us start mechanical properties of fluids. Let us see what is meaning of fluid mechanics. It is a branch of physics which deals with the study of fluids at rest and in motion. So this fluid mechanics can be divided into two branches. One is hydrostatics, another one is hydrodynamics. Now let us see what is this hydrostatics. It is a branch of fluid mechanics which deals with the study of fluids at rest. Hydrodynamics means it is a branch of fluid mechanics which deals with the study of fluids in motion. The common name for liquids and gases is fluid. Actually, this fluid is a Latin word. Meaning of that one is to flow. If we see in case of solids, solids have definite size and shape. The size and shape of solids changes slightly under the action of external forces. When a liquid is poured into vessel, it acquires the shape of the vessel with free top surface. This shows that the liquid has definite volume but not a definite shape. A quantity of gas can fill in the container without free surface. Therefore, gases do not have definite shape and size. So what is meaning of fluid then? It is a substance which can flow. Related to fluid, let us learn some words. That is fluid thrust. Then let us see about fluid pressure. First let us see fluid thrust. It is the total normal force exerted by the fluid at rest on the surface in contact with it. Means what? Let us consider a liquid in one container. Okay. Then this liquid which is inside the container, if you observe, it is applying the force to walls of this container. So fluid is applying its force on walls of the container. So this force applied by the fluid for the surface of the container is called fluid thrust. Condition is fluid must be at rest. So what is fluid thrust then? It is the total normal force exerted by the fluid at rest on the surface in contact with it. Okay. Now let us see what is fluid pressure. Pressure already we know, that is force divided by area. Here we will take it as it is the fluid thrust per unit area. So pressure can be written as pressure is equal to thrust divided by area, or you can write it as force divided by area. Then its SI unit will be Newton per meter square. Unit of force is Newton. Unit of area is meter square. So it is Newton per meter square. This is also called Pascal. It is notation for that Pascal is capital P small a. Pressure is a scalar quantity because it has only magnitude, no direction. And its dimensional formula is 1 in mass minus 1 in length minus 2 in time. Now let us take one small derivation, that is expression for liquid pressure. For that let us take one container. In that container let us fill some liquid. Let this liquid has a density that is rho. Then as we now learnt that this liquid will apply the force on the walls of the container. So here you can observe applying force is nothing but it is weight of the liquid and it is acting downward direction. And this is free surface. Okay. So this has a area. Let us denote it as A. And let us consider a point O inside the liquid and it is at a height h from this free surface. So O is at a distance of h from the free surface. Okay. Now let us see the points. How to write. Consider a vessel of area of cross section A filled with a liquid of density rho. Let O be the point inside the liquid at a depth h from the free surface of the liquid. Then we want to calculate pressure. So write the pressure. Pressure is equal to what? Force divided by area. Here force means what? It is nothing but weight of the liquid in the vessel. So pressure P is equal to what now? Weight of the liquid in the vessel divided by area of cross section of liquid. Now weight, how will you calculate? W is equal to what? M into G. Substitute the value. So P is equal to M into G divided by area of cross section. We have considered it as A. So we got the equation pressure P is equal to mg divided by A. But we don't know how to, means here mass of the liquid is not known but density we know. So let us express this mass in terms of density. How to express? As we know this one, density is equal to mass divided by volume. So mass is equal to density into volume. Notation for mass m is equal to rho into v. So instead of this m in the equation we can substitute rho into v. Okay. But what about this volume? Instead of volume, we know that volume is nothing but here in this case it is area into height. So volume is area into height. So V is equal to what? A into H. So what we have to do now? Instead of M, we have to write rho into V, but V is A into H. So P is equal to rho A H G divided by A. Here this A and A get cancelled. Okay, this capital A, area of cross section, it get cancelled. So what remains now? P is equal to rho G H. What is rho here? It is the density of the liquid. And what is G? Acceleration due to gravity. And what is H here? It is height. Or you can say depth inside the liquid. So what is expression for liquid pressure then? P is equal to rho G H. Say if we consider atmosphere, means pressure exerted by the atmosphere, then we can write the expression as total pressure, let us represent it as PT is equal to PA. What is this PA now? It is pressure exerted by the atmosphere plus rho GH. Then what are the factors affecting this liquid pressure then? Very simple to answer. Rho GH we are writing means all these three factors are affecting. So first one is pressure is directly proportional to density of the liquid. It is directly proportional to height of the liquid and it is directly proportional to acceleration due to gravity. Okay, then we will get one more important word here, that is gauge pressure. So what is this gauge pressure? Gauge pressure at a point in a liquid is the difference between pressure at a point in a liquid and atmospheric pressure. Means what? Liquid pressure is nothing but it is gauge pressure. Let us denote this liquid pressure as PL is nothing but it is PT minus PA, where PT is total pressure due to both liquid and atmosphere, means total pressure. PL is liquid pressure, then PA is atmospheric pressure. Then what is this atmospheric pressure then? It is the pressure exerted by the air surrounding the earth, and this pressure is due to weight of the air. See, the factors affecting the liquid pressure, whatever we learnt, no? This one, pressure is directly proportional to density of the liquid. If you want to know about more, this one means in the barometer means it is instrument which is used to measure pressure. In the barometer, mercury is used to find atmospheric pressure instead of water and other liquids because of high density. We can use water also, but tube of large length is required at that time. Then second one, we are saying pressure is directly proportional to height of the liquid. The bubbles of air in water become larger and larger in size as they move up. I think you know this one. What I told? The bubbles of air in water become larger and larger in size as they move up. This is because as they move up, height of water decreases, hence pressure on the air bubble decreases. Due to this, the size of the air bubble increases. Okay, so these points try to remember. Then let us continue.